Have you ever stopped to wonder how an app or a website just remembers your name or your phone number? It seems like magic, but it's actually one of the most basic, fundamental ideas in all of programming. So let's pull back the curtain and see exactly how computers store information. So let's just start with a really simple question. You type your phone number into a form, you hit save. Where does that number actually go? I mean, it can't just float around in cyberspace, right? The program needs a specific place to hold on to it, a spot it can find again later. And this, right here, is the core problem we're going to solve today. And the solution to that problem is something called a variable. Now, that's the official fancy term, but I want you to think about it in a much simpler way. A variable is just a container. Seriously, it's like a box or a bucket, a labeled spot in the computer's memory that's designed to hold one piece of information for you. That's it. So in our phone number example, the variable is the container, and the number you typed in, that's the data that goes inside. That's the big secret. We just created a labeled box and we put our information inside of it. It's a simple idea, but it is incredibly powerful. Okay, so we know we need these containers. The next question is, how do we actually create them in our code? Well, like any good system, there are a few simple rules to follow. Let's take a look at how to properly build and label our containers. To create a variable, you always start with a special keyword. Now, in older JavaScript, that keyword was var, but today, modern programming gives us two much better options, let and const. This table kind of breaks down the choice between them, but here's the most important part for now. Look at that column, can value change? In modern projects, you'll pretty much always use let for things that might change and const for things that shouldn't. We basically just avoid var these days. Here is a perfect example for lets. Let's say we create a variable called age, and we store the number 20 in it. Well, next year, on your birthday, that value needs to change to 21, right? Because we used let, the program lets us make that change. No problem. It's flexible. But what about values that should never change? Think about the mathematical constant pi. It's always 3.14, and so on. For that, we use const to create a constant variable. This tells the program, hey, lock this value in, protect it. If you try to change it later, the program will throw an error, which is actually a good thing. It stops you from making accidental mistakes in your code. And just like you label a real box, your variable needs a name. There are just a few quick rules to follow. Names can't have spaces, and they have to start with a letter, an underscore, or a $sign. And if your name is made up of a few words, the standard way to write it is using what's called camel case. The first word is lowercase, and then every word after that starts with a capital letter. Okay, so we've built our containers and we've labeled them. The next logical question is, what kind of stuff can we put inside? And this brings us to a really important concept called data types. Now, while there are several types of data in programming, you are going to use these three about 90% of the time. First, you have a string, which is just any piece of text, always wrapped in quotes. Second, you have a number, which can be a whole number, a decimal, doesn't matter. And third, you have a Boolean, which is just a simple true or false. It's perfect for answering yes or no questions in your code. Now, what if you forget what kind of data is in your container? Or maybe you're looking at code someone else wrote and you need to check. Well, programming gives us this handy little tool for this called typeof. You can use it on any variable and it will tell you exactly what kind of data is sitting inside. And here you can see it in action. If we ask for the type of the name Ram, which is obviously text, it correctly tells us string. If we ask for the type of the number 28, it tells us number. It's a really simple but essential tool for understanding and, debugging your code. So we've covered the containers, the rules for making them, and the stuff that goes inside. Now for the fun part. Let's put all these pieces together and see how they work in a real practical scenario. A super common thing you'll do is create a message that mixes plain text with a value from a variable. The old way involved adding strings together with a plus sign, which can get pretty messy. But the modern way, called template literals, is just so much cleaner. You use these special backticks instead of regular quotes, and you can pop your variable right inside the string. It's easier to write and way, way easier to read. So why does all of this really matter? Well, understanding these fundamentals is absolutely critical. As you get more advanced, you'll even learn the subtle differences between special empty values like undefined and null, which, by the way, is a classic tech interview question that really shows if you have a deeper understanding of how data works. So let's do a quick recap of the most important things to remember. First, Variables are just containers that store data. Second, use let for values that you expect to change, and use const for values that need to stay the same. And finally, every piece of data has a specific type, like a string for text, a number, or a Boolean for true or false. And that's really it. What we just covered, this idea of storing information in a labeled container, is the absolute foundation of what makes all software work. I mean it. From the simplest calculator app to the most complex artificial intelligence, it all starts with this one simple idea. You've just learned the fundamental building block. The only question left is, what are you going to build with it?